Welcome to this Sahara 4 exercise. In this exercise, we will start working with the log window in order to show the different information that has been imported in the previous exercise. So for that, we'll open our Sahara project, and here we will select the well that will be the example D74, and here we will go to View, Logs. Once here, we will find a blank window because we don't have any template loaded. Now, once here in the log window, we can see that we have three different areas. Here we have the configuration tree where all the different logs and the different curves that are going to be plotted will be displayed here in a tree format. Then we have here the configuration of properties of each different branch. We will be able to select a branch and we will have different options depending on the branch where we are sitting on very similar to what we see in the production window when we select, for example, an axis here, and we have different properties depending on the side of the branch that we are standing on. And finally, the third area, the biggest one, is going to be the log viewer, where we are going to see the display information. Here, if we want to add a new curve, for example, we can first we should go right click on over general settings, and here we can insert a track or add a track. The add button is going to add it at the end, and the insert button is going to add it at the start. Here we have the two different tracks that are in this case by default is going to be assigned as a log type tracks. So in this case it's going to be called logs and logs1. Here we have different kind of tracks that we can modify by clicking on this option, and here we can define the name of the track as well. Then after adding a new track, we can go to right click here and add a curve over the track. So now we have a log curve added to this log track, and we can add more and more curves, creating this tree shape structure that is going to classify the different tracks and the different logs that can be added into them. If we select a different kind of track, for example, let's say that we add a layer one, we cannot add a curve over here because this track is already reserved for showing the different layers that we have available. We can either hide or show the different tracks by clicking here, and we can also hide or show the different curves inside the tracks by clicking in any of these checkboxes. Another option that we have available by right clicking on the log track is add shading. This will show an area between a curve or a value and a curve that is going to have a different color, it's going to be filled with a different format, but we will do an example later once we load an example template, which we can do now. Let's do it now. We can, with these buttons here, we can either hide or show the configuration window. We can create a new template, a blank template. Here we can load a template or save the current template that is selected. So now I'm going to just load a template here, and we'll have an example. And this is going to be better to show the different functions in general settings. So here we can set up the scale if you want to have free scale or a set scale. Here, for example, we have 1 to 200, 1 to 500, to 1 to 1000, and here we can increase it further. In this case, I'm going to use free scale. We will use the best available scale to show all the information. Here we can decide we want to see the information in feet or meters, and more importantly in measured depth or true vertical depth or true vertical depth sub c. Here, if I change this, we will see that which is the depth at the true vertical depth. Here in true vertical depth sub c, that we see that, as we explained in a previous exercise, the more deep I go, the more meters I have under the sea level, so it's going to be more negative. And here you can modify to feet, for example, if you prefer to see the information in feet. Here we can set up a secondary scale. Maybe we want to compare the measured depth against the true vertical depth, or true vertical depth sub c. So now here we can see the two scales together. Here we can select or unselect if we want to see a header for each different log. In this case, I will leave it on because the font of the header as well, the height assigned to the header, if we modify, it's going to be increase it, for example, like this, or decrease it. Well, I cannot do it less than 20, but let's say decrease like this. Not very useful because we cannot see much of the header. Let's keep it on 50. It's an optimal value. And here we can display the peaks. The peaks here are the tops that are the tops and base of each layer identified along the tracks. So here we can see the top and bottom associated with this layer on this well. Normally we will have the top as a red line and the bottom as a green line, and we can check it for the whole well. In this case, as this creates quite a lot of visual noise when we have plenty of layers, I will unselect it. Now, as the next part of the exercise, we will add a new track. Let's go here, general settings, add track. This new track is going to be called res from resistivity, and this is going to be this log type because we will load the resistivity here. And now the track scale will be logarithmic. We won't change anything here about the width of the offset for now, and the subdivisions we will just keep it at 2 subdivisions, and the base means the logarithmic base that we are going to use. Now, before we move on adding the curve, I would like to review these options a little bit further. For example, here we have the different logs that we have available. For example, the depth scale is going to display the depth grids according to the scale or scales defining the general options. As we saw, it could be TBD sub C, or could be, for example, TBD or measure depth MD. Then the layer is going to show, we have already one here, this one that is showing the different layers in the project. Basically it's going to show in this track the position of all the different layers for this well, and how it allow you to see how it's associated with, for example, the spontaneous potential for this layer in this log. Then the zone will show us the different zones with operations such as perforation, cementing, for example, acid treatments or tests as well. We don't have them yet in this project, but we will do in a later exercise. We will import all this well work information. Then logs is the ones that we have here with different logs, is potential, gamma ray, density. We will create the resistivity one now. The stack is going to display stack curve. Normally you will use it to generate lithology logs as well. The flags here we will display also well work information or dynamic layer attributes or another registers with a color range. Here the nodes will allow us to show different nodes, what is called nodes in depth, where we can create a text file that will be imported at a certain depth into the log file. For example, if we want to do some annotations associated with well works, maybe for example, let's say that we did an simulation on this layer here because we like the SP value and the gamma ray value, and we can add the well work by using the either flags or the zones, and later we can also add the note saying, okay, we did this acid treatment, for example, or this, I don't know, hydraulic fracturing because we see high potential due to this gamma ray. You could add all this text as a node in depth that is called. You will be able to show the different nodes associated to the well, and you can also load a depth into the node, so it can be shown here. Then here we can use this kind of tracks for showing PLT or ELT information. This data will show data at the layer level, can be, for example, petrophysical data or monthly production, daily production, or for example sporadic data. For all those that are date dependent, for example sporadic data or monthly productions, no petrophysical data because petrophysical data is not time dependent, but for all the other ones, the one that is going to be the date that will be considered for this data is going to be the one that is active on this slider, on the date selection slider. um, Here the other ones available are wellbore diagram. This will allow you to show the wellbore diagram associated with this wellbore. The perforation status will show us the different perforations that are loaded into the project, which in this case we don't have any yet, but we will do in a future exercise when we see well works. And we will have the ones that are active in black and the ones that are inactive in red, because for example they are cemented or they are above a packet or below a plug. And yeah, and that will be everything for the type of logs. um, Also here you can put the name of your log track, as I did with resistivity, in this case res. The width will show us the relative width of the track. We can modify it. Obviously if I increase it, I'm going to reduce the relative width of the other ones, so we'll keep it in 100. Here with the offset option, we can define a space between the track and the one on the left. So we will for example put it here, and we'll have a space here that we can create between the different tracks. I will leave it as 0. Here we can show the different grid. In this case, this is going to belong to the scale, to the grid of associated with the curve. In this case it will be resistivity. We can hide or show it. The same with the depth grid that can be seen here. We can hide or show it. And with this color option we will see, for example, we can modify it here, not the best color. Let's use it, for example, this one, or we may want to use this one. Let's keep it in gray as we had before. And here with the scale we can set it to linear or logarithmic, as I did before. In the scale of linear, let's modify to linear for a moment. We can select only the subdivisions here that we want. It's going to divide the linear scale in segments of the same width. And in the case of the logarithmic scale, you have to select how many subdivisions you want, and which is going to be the base or the start of the curve. In this case I selected 2 subdivisions and the base is going to be 2. Yeah, so I think that will be everything. I just wanted to review this menu in more detail, the menu associated with the tracks. But now let's add that resistivity curve. So we will go to add curve and we will select our curve. Note here that you can select either aliases that are going to be listed first. Here, as we discussed in the previous exercise, this is going to be a group of mnemonics that are loaded into the Sahara project with a priority defined for each different group. In this case, we will use one of these aliases. Later, if you want to show a specific curve, you can do it, and you have to scroll down further. And here we are going to see all the different mnemonics that have been loaded with the last files. But we will keep it simple and go with this one, resistivity, deep resistivity. And here we can see our curve. Now let's start modifying this. I will first modify the curve and then explain what each different menu does. So first let's modify this by -1. The units here are okay. In ohm meter, the format here is fine as 0. Let's modify this color with something more better, like this, or maybe something like this. This is better. Let's keep it like this. I think this is okay. If I no, I think that with thickness 1 is okay. Let's add another curve here, and this is going to be mid resistivity. So add curve. Now instead of using deep resistivity, we are going to use mid resistivity. We will also use exponent 1. Let's keep the same like this. The color we will use red for this one. Right. And then now we will use the shallow resistivity. We will add that one by going here, add curve. Shallow resistivity should be here. We will also modify the exponent, and let's modify the color to green, like this. So now I will open this, and now we have our resistivity track ready. So now the different options that I modify. First, obviously, we will here we will select the curve that we want to see. In this case, I use different aliases belonging to the different resistivities that we have. We have deep resistivity, shallow resistivity, and mid resistivity that will show the resistivity at the different inspection ratio of the well. And here the exponent option is only going to be enabled when we have logarithmic scale track, allow us to enter the exponent of the initial value of the scale in scientific notation. So what we need to understand here is that this exponent option is going to define, working with this subdivision and base option as well, which are going to be the limits of our logarithmic scale log. So in this case, the base is 2, which means that we are going to start with 0.2, then go on with 2, and then with 20. If I modify this, the whole thing is going to be changed because this is in the track level. It's going to change as I modify from 2 to 1. Now the start is going to be in 0.1, then in 1, then it's not clear because I'm selecting another value, but here the one in the middle is 1, and then in 10. If I modify this further, let's say that I pick 5, then I'm going to start with 0.5, then go on with 5, and then with 50. Then the subdivision is going to define how many numbers of magnitude I'm going to include in the logarithmic scale. So for example, if I add another one, I will go to 500, as you can see here. So we are going to have 4 different levels of magnitude, sorry, 3 different ones. So it will be 0.5, 5, 50, and 500. We will have 3 subdivisions or 4 order of magnitude increases in order of 10 in the logarithmic scale. So I will go back to 2, and I will go back here as well to 2. And in the curve level, I can define which is going to be the starting exponent. So if I modify this, let's say I go to 0, the curve, instead of starting by 0.2, is going to start in 2. So using these different options, I can modify which is going to be the starting point of each different curve, and how many, which is going to be the base of the logarithmic scale. So, it means, for example, if I select 1, it's going to be 10, 100, 1000. If I select 2, it's going to be 20, 200, 2000, and then and so on and so on. And the subdivision is going to show how many increases I will have from the base defining the exponent here in this option. So moving on, we also can see the units and format here. We can select different units for the different curves. If I modify this, it's going to be get out of the scale, but let's keep it what it was. Also we can obviously modify the different colors. Now the next step will be using the shading option to mark the places where we have sandstone. For that we will use the places where these two curves cross. In this case, where the SP gets more negative and the gamma ray as well gets more close to 0, we have a lower value of gamma ray and a more negative value of spontaneous potential. We can say that where we have a cross, it's more likely that we have a sandstone body instead of clay. So for that, we will go to here, right click on the name of the track, and go to add shading. Here we will define the shading as we can define as curve to value, value to curve, or curve to curve. In this case, as we are going to define the shading area as the place where the two curves meet, we are going to select this option curve to curve. We have to define which is going to be the curve on the left and the curve on the right. Here we will select on the left SP and on the right gamma ray. Now we will select which style we want here. We will keep it on hatch. Here we will select which hatch we want to use. Here something that is related to sandstone. Let's look for it. Salt. There should be at least one that we can use here, sandstone, and we will use a yellow color here. No, sorry, this should be the color. The color should be black. The background should be in yellow, and we will select the hatch, the the shading. So now you can see that we have a good coincidence between the places where the SP and the gamma ray cross each other, where we have a lower value of SP and a higher value. Well, it will be the scales are the other way around, so it should be a more negative value of SP and closer to zero value of gamma ray, a lower value of gamma ray. We can see that in these cases, in these crosses, we have sandstone or sandstone bodies, and it's quite coincident to the layers that have been defined previously across the cross section of the well. Here, see, we have some that maybe because they are too little don't have yet a name, but here we can see that we have good coincidences across the well. So in this case, I think that that should be all. Remember that you can use these shading options as well to to for example consider a value. For example, if you want to use a shading to mark all the places where gamma ray, for example, is lower than, I don't know, 50, in this case, in this example, you can use it as well. That will be another option to show the places where we have sandstones. And another thing to consider here is that we can always save our template here. So we can, for example, we can call this SP gamma ray. Let's call it complete, because we added quite a lot in this exercise to this template. So yeah, those are some basic functions associated with the log window. That will be everything for this tutorial, and thank you for watching. Have a great day.